Welcome back to another exciting chemistry lesson. In the previous lesson, we learned how to look at the periodic table and determine the number of valence electron in each atom based on the group number. The group number tells you the number of valence electron. For example, all the atoms in group 1A has 1 valence electron, and all the atoms in group 3A have 3 valence electron. Now we are going to look at that facts and draw Lewis dot structure or electron dot structure to show how many valence electrons are in an atom. Well, before we do anything, we have to review the fact that here we have an X atom, okay? And of course, in order to be stable, we need to be one of the noble gas to have the same electron configuration as one of the noble gas. So in this case, if we think about it, okay, all the noble gas except for helium has an exception, okay? There are 4 locations because electrons are negative. They want to repel each other, so they stay far apart. Now, what's happening is that each one of them can contain one electron going one direction, the other one going opposite direction. But before we do anything, we have to realize, think of one arrow as one electron. One go up, okay? The other one go up. Now, to pair up in the same location, the other electron must go in the opposite direction. And that's the only way that's possible. And each one of the boxes here is called an orbitals, okay? So think of orbitals as a region in space where electrons are occupied. If one's going that direction, the other one going the opposite direction. So now we have a magic number of octet, again, except for helium. Now let's draw electron in terms of dot. Well, if this first dot go right here, the second dot or the second electron must be go on the other side, okay? And it works the same way on top and bottom as well. Now let's go to the third one and the fourth one. Well, it could be the top one and bottom, but you notice it's trying to stay as far apart from each other as possible. And the fourth one go here. Now we continue to draw. Of course, now we have to pair them up. So in this case, I'm going to put one right here, and then the other one right there, another one right there, and another one right there. The key idea is this. Electron, they want to repel from each other, so therefore they want to stay as far apart from each other as possible. Now I'm going to draw each one of them for you, for each group for you, okay? So first of all, I have my atoms in group 1A. I want to draw hydrogen, okay? So hydrogen, look at that. It's just one dot, okay? And then for group 2A, let's draw beryllium, Be, okay? So I want to draw one dot here, the other dot over there. Isn't that nice? Now for group 3A, we have boron, okay? We have one dot here, 2 dot here, 3 dot here. Of course, the third dot can be on the bottom as well. For carbon, we have 1 dot here, 2 dot here, 3, 4. There you go. Isn't that easy? And all the atoms in the same group have the same or similar Lewis dot structure. In group 5A, we have nitrogen, 1 dot, 2 dot, 3 dot, 4 dot, and go back the 5th dot right there. And then for oxygen in group 6A, 1, 2, 3, 4, 5, and 6. Okay? And then group 7A, we have fluorine, 1, 2, 3, 4, 5, 6, and 7. There you go. But here is the exception for helium. Helium is stable. So in this case, the electrons are not going to be on the opposite side. Rather, it is paired together. So that is an exception for helium. But what about the rest of them? Neon, it has 8 dot. 1, 2, 3, 4, 5, 6, 7, 8. And that is all we have to do when we have to draw electron dot or Lewis dot structure to represent how many valence electrons are in each atom. Just be careful with helium, okay? And as always, we will see you next time on another exciting chemistry lesson.